You might remember from grade school that volume is measured in cubic units. What exactly does that mean? For an object to be, 40 centimeters cubed. What we're saying is that for a cube that is 1 centimeter by 1 centimeter by 1 centimeter, which this one is a little larger than that, but we're just going to pretend that it's a cubic centimeter. So its height, width, and depth are all 1 centimeter. If an object is 40 centimeters cubed, that means that 40 of these could fit inside of that object. That's what it means. Now that doesn't necessarily mean that they would have to fit like all in a row and up and across like a rectangular prism. It doesn't have to be that kind of shape, but for more of an irregular shape, it could still be 40 cubic centimeters. You would just have to imagine maybe more of those cubes being like cut and fitting in like little pieces of it, especially if it has like something circular in there, like a cylinder. These aren't going to fit perfectly because they're cubes, but that doesn't mean that we can't say it is cubic units. So just to give you a visual before we jump into using some formulas, just kind of show you where some of those formulas come from. I've got this, I don't actually know what it is. Maybe it's like a pencil, I don't know, I put my mail in it. If we've got this object and we're trying to figure out how many cubic centimeters, first let's just start by seeing how many of these cubic centimeters are going to fit in the bottom of the container. So these don't fit perfectly, there's a little bit of space in there, but it works pretty well for what we're trying to visualize. So the amount of dice that I just fit in here, it's a 3 by 13. So there are 39 dice that fit just in the bottom of it. Now, if I'm trying to figure out the whole volume, you might be thinking, let's fill up this whole thing with dice, but oh man, I don't have that many dice. But that's okay, we can be smart about this. If I know that 39 dice are going to fit in the first level, that means that 39 dice should fit in the second, 39 in the third, 39 in the fourth. I just have to figure out how many levels there actually are. So all I need are a few more dice to go and see how tall. So there's 1 and there's 2, and so it's about 3 dice high. So to figure out how many dice fit in this container, I don't need to fill up the whole thing. I just need to see, okay, this was 39 plus 39 plus 39, or 39 times 3, which is 117 dice. Or 117 cubic centimeters fit inside of this container. Or if we simplify even further, remember when I was looking at how many dice fit in the very bottom of this? I actually didn't count them. I just counted the length and the width because I knew that multiplying them would give me the area of the bottom. So I actually just needed to multiply my length times width times height. And that is how you find the volume of a rectangular prism. And really any prism is going to be similar because as long as we can figure out the area of the base, we can multiply that base by the height to see how many of those layers we need. Now if we're looking at a cylinder, we're not going to want to estimate with dice because those aren't going to fit very well, but I have other ways of finding the area of my base using the circle formula, and then multiplying it by the height is going to have the same effect as it did with our rectangular prism. So the formula for the volume of any prism is this right here, this area of the base times the height. Remember that uppercase B is the area of the base. Now for a rectangular prism, the area of that base is length times width. So a lot of times you'll see that the volume of a rectangular prism is length times width times height. But this area of the base times the height works for any prism. So it's kind of nicer to have memorized if you're going to remember something. So for number 1, if I'm taking the area of the base, and remember with a rectangular prism, it really doesn't matter what you choose to be the base. Sometimes it makes the most sense just to make the bottom the base. So for this one, if my base is this 9 by 17, that means the area of my base is 9 times 17 times my height of 24. So I end up just multiplying length times width times height, and we should get 3,672, and it was centimeters, so it'll be centimeters cubed. So let's look at a different type of prism. Number 5 is a triangular prism. So we're still going to be using that same formula, the area of the base times the height, but now our base is different. So I have to adjust that to however I need to find the area of this base. So since my base is a triangle, I will be using that 1/2 base times height. A lot of different bases and heights here, so make sure you're clear on what you're using. For that triangle though, my base is going to be 11 and then the height is 5.4. Remember, when you're choosing the base and the height for any polygon, that we're making sure the height is perpendicular to the base. So that's what makes 11 and 5.4 the base and the height of that triangle. And then the height of my figure, so not just the triangle, but the height of my triangular prism, is always that distance in between the two bases. So my distance in between the two bases will be 16. And then multiplying them all together, I should get 475.2 millimeters cubed. So as long as it's a prism, using that same formula, volume equals the area of the base times the height, go ahead and pause the video and try number 6 on your own. That base is a trapezoid, so be careful with your finding the area of the base. Make sure you use the formula for a trapezoid. So we should get this 11,187.5 meters cubed. Make sure with your trapezoid that you're choosing the right base 1 and base 2, so 14 and 36 are the bases. And then the height of that trapezoid should be this 17.9. Sometimes it helps to go ahead and redraw that base off to the side, maybe even finding the area of the base and then just plugging it into that base times the height, area of the base times the height. Sometimes that's helpful. Make sure that your distance in between the two bases is the height of the figure, so it should be 25. So in the same category, really, we'll look at a cylinder, and even though we don't really call it a prism because it has circles involved in it, it's going to work the same way because it's still uniform throughout the figure. Once we find that circle, it's going to have that same area over and over all the way up the cylinder. So we can still use that area of the base times the height, just the area of my base is going to come from pi r squared. So I'll have pi times my radius, in this case will be 5.5, so I do have to half it. So there's the area of my base, and then my height is still that distance in between the two bases, so it'll be 21. Again, anything that I've got pi involved in, you might be keeping it in terms of pi, but you also might be rounding to the nearest tenth or whatever, so just be careful about that. I'm going to go ahead and round here, and we'll get about 1,995.7 meters cubed. The volumes of pyramids and cones are actually very similar to the volumes of prisms and cylinders. The volume of a cone ends up being exactly 1/3 of the volume of a cylinder that has the exact same base and height. So if you filled up a cone with water that was the exact same height and base as a cylinder, then you should be able to fill up the cone 3 times and pour it into the cylinder for it to match that volume. Here's a visual of that. And pyramids turn out the same way. So for both pyramids and cones, our formula for the volume is this 1/3 area of the base times the height. So really calculated the same way as prisms, just having to take 1/3 at the end. So looking at number 1, I'm trying to get a glare off of there. We have that 1/3 area of the base times the height. So the base of this figure is a rectangle multiplying my 10 times 11. And then the height of my figure, and make sure that it is perpendicular to the base, and this one is 16. Remember that with the cone and the pyramid, you could get the slant height instead, but that is not part of our formula this time. We want the actual height. So if they do give us the slant height instead of the actual height, we'll have to do some Pythagorean theorem. And then this last step here, I would make sure you go ahead and do this on your own in your calculator and make sure that you're able to. I see a lot of students that feel confident just with where the numbers came from and okay, I can do it. And then later putting this into their calculator on their own is much more challenging. My suggestion would be to go ahead and multiply 10 times 11 times 16, so all of the numbers here, and then hit enter, and then divide it all by 3. You should end up with 586.7 inches cubed. The other way that you could put this in your calculator is putting in 1 divided by 3 for 1/3, but make sure that it's in parentheses. So in parentheses, 1 divided by 3 times 10 times 11 times 16, that's fine too. But something about that fraction gets students from time to time. So make sure that you can actually put that into your calculator and that you're getting what I'm getting. So I do want you to try one where you're not given the actual height of the figure, you're given the slant height. So go ahead and pause the video and just see if you can set up and solve for the height of the figure for number 3. Okay, so setting up that right triangle, it might help to draw it inside of the figure to where you can see that's the right angle right there. Remember, our height has to be perpendicular to the base. So we're looking at this right triangle, but then it also helps to redraw it outside of that triangle or outside of the pyramid, because this length right here is going to be half of that side. So it's going to be 7 for that leg. And then the hypotenuse is 25, looking for the height. When you use Pythagorean theorem, you should get 24. So now going on into our formula, we've got 1/3, the area of our base is a square here, so it's going to be 14 times 14, 14 squared, and then we found the height to be 24. So again, go ahead and plug this into a calculator, make sure that you can find that on your own, but you should get 1,568, and it is feet cubed. Okay, let's throw a cone into the mix, and remember that our formula is the same, 1/3 area of the base times the height, but that area of our base, since it is a circle, is going to be pi r squared. So our radius for this one is 9, and then the height of the cone is 17. And let's leave this one in terms of pi. So in terms of pi, we should get 459 pi yards cubed. Now with the cone, we can have that same situation as we did with the pyramid, where maybe they give us the slant height instead of the actual height. And same thing, I would go ahead and draw in my right triangle. Make sure that you're using half of that diameter, so you should be using the radius here. And then my 22.5, my slant height, is the hypotenuse, and I'm looking for the actual height. We're not going to go through another one of those, but it could happen here as well. So make sure you're using the actual height for either of these. So our last solid is the sphere, and its formula for the volume is this 4/3 pi r cubed. Yes, cubed. So looking at example 1, again, this is one of those that is not too difficult to set up, but can be challenging to put in the calculator. So make sure that you are following along and actually try it in the calculator with you. Got kind of a glare there. Okay, that's a little bit better. So we've got 4/3 pi, our radius is 7 cubed. Let's keep this in terms of pi. So see if you can go ahead and multiply your 7 cubed and your 4/3. You should get about 457.3 pi inches cubed. If you're not getting this, first make sure you didn't multiply it by pi, because it is in terms of pi. But then my hint to you is you can either multiply 4 times 7 cubed and then divide that whole thing by 3, or like we did with the 1/3, you can put it in parentheses and have parentheses 4 divided by 3, close your parentheses, times 7 cubed. So try it a few ways. If you're still not able to figure it out, let me know. Okay, go ahead and try number 2 on your own, and we'll keep this one in terms of pi as well. See if you can plug in the radius and get the volume for the sphere. So here's what you should get in terms of pi. If you're still not getting that, I'm going to show you the 2 different ways to plug this into your calculator. So my 16.5 cubed, so you're using a caret here, probably raising it to the 3rd, and then I'm going to multiply by 4 and hit enter, and then I'm dividing the entire thing by 3, and that's how you'd get the 5,989.5. The other way that you could look at it is taking your 4 divided by 3, so that's your 4/3 in parentheses, and then multiplying it by 16.5 cubed. And that will get you the same thing. If you're interested in learning more about solids, you should Google platonic solids and explore them a bit. There are only 5 of them that exist.